Hello everybody, Mike Dolges here to present our Rich STEM activity screencast, and the name of my activity is a paper circuit flashlight design. And to provide you a brief summary of the activity, I would have my students work in groups of 2 to follow the engineering design process to build a working flashlight prototype using the components provided. And at least for me, in my technology education classroom, this activity would most likely follow a lesson or a unit on DC series circuits, resistors, current flow, Ohm's law, things of that nature. This would be a culminating activity for me so that they can apply what they have learned. And I also wanted to provide for you, I came across a Circuit Builder app. It's available in the App Store and also on Google Play. If you have or are using any devices in your classroom, you may find that useful. And we would be following our engineering design process to make our prototype. And so the first step is to ask, what is the problem? And I would present this to my students as a real-world situation, such as a catastrophic event that could potentially be a severe storm or something like that has left your home without any electricity. So I would ask then, can you and your partner design and create a working flashlight to enable you to see in the dark? And I would also have a few criteria and constraints on the activity. I would make sure that they go through at least 2 design process iterations so that they're able to make improvements to their design. And then a few constraints would be placed on the project as well. One that I wanted to make note of was I would make them use a penny to be used as the switch. I do not have a switch at my disposal to be used, so I thought, why not use a conductive material that could be easily removed to close the circuit and act as a switch. So I thought this could also be a good opportunity for students to explore conductive materials as well, and you could also discuss some of the science behind conductive materials. And then the next step is to imagine, brainstorm ideas, choose a solution. You can see a few thumbnail sketches there that I came up with. And then we had to plan. There's my assistant, my oldest son Luke, there to help me. And we made a detailed sketch, a wiring diagram, and the materials needed. And then we began creating. Okay, we had to build and test it. So we decided to make this out of cardboard. You can see there that we have the LED coming through the top of our flashlight. I ended up using a small resistor as well so that I did not burn the LED out. And then over here you can see the cutout that I made for the penny to go in and act as our switch. And so here's the completed prototype. Right here is where the penny would be dropped in, and that would power on our flashlight. And so the last step of the design process is to improve, make it better. So we decided to use our sensor tag to measure the light output of our flashlight. And you can see over here that we had 281. And then we came up with the idea of making and building a cone, lined it with aluminum foil to see if we could improve our light output, and then we retested it with the sensor tag, and we came up with 462. So we were able to make an improvement upon our prototype. Here's my design tool 5.1 with the STEM lesson specifications. And lastly, I want to thank you for watching. You can see my son Luke there using the flashlight in the dark. I will post on our discussion board along with the screencast. I created a handout to go along with this activity for the students, and there's also a scoring rubric included as well that all of you are free to use if you wish. Thank you again.